Hi and welcome to John's Maths Book. In this video we're going to be looking at basic integration. If you like the video then please hit the like button and I'd be delighted and honoured if you'd subscribe to the channel if you haven't already. Without further ado, let's go over to the whiteboard. We saw in a previous video how the area under a curve could be sliced up in the x direction to create rectangles, and the rectangles then summed to find the area under the curve. We also saw that as we used more values of x, and therefore more rectangles were created, we had a better approximation of the area under the curve. We then went on to show that this process of finding the area under the curve was called integration. Integration is the reverse of differentiation, or the antiderivative. So for example, if dy by dx is equal to 2x, what is y of x? We're asking what function when differentiated gives us 2x. In this case, y of x is equal to x squared plus a constant c. So why is there a constant c, I hear you cry? The constant c is very important because there are many functions whose derivative is 2x. Let's take a look at some examples. So if we have y is equal to x squared plus 1, dy by dx is equal to 2x. If we have y is equal to x squared plus 3, dy by dx is also equal to 2x. If we have y is equal to x squared plus 5, again dy by dx is equal to 2x. So it follows that y equals x squared plus c, the derivative dy by dx is equal to 2x. So now let's look at the notation we use when integrating. So the integral symbol is an elongated s. Next is the function we're trying to integrate, so f of x. And then dx means the direction in which we're integrating. So dx means we're integrating along the x-axis. So effectively we're slicing up the x-axis and summing up those tiny slices to find the area under our curve. A definite integral is when we integrate between 2 points on the x-axis. So we integrate from x is equal to a to x is equal to b. This is a definite integral. If we're integrating without these points, then it's known as an indefinite integral. When we're using a definite integral and we're using it to calculate an area under a curve, we're calculating the area between these 2 points a and b. One of the rules of integration is known as the power rule. This says if we want to integrate x to the power of n by dx, this is x to the power of n plus 1 divided by n plus 1 plus a constant c. Let's look at some examples of using the power rule. So let's say we want to integrate x to the power of 5 dx. This is equal to x to the power of 5 plus 1 divided by 5 plus 1 plus a constant c, which is equal to x to the power of 6 divided by 6 plus a constant c. Let's look at another example, the integral of x to the power of 7 dx. Using the power rule, that equals x to the power of 7 plus 1 divided by 7 plus 1 plus a constant c, which equals x to the power of 8 divided by 8 plus a constant c. Now let's look at a simple definite integral. Let's suppose we want to integrate the function 2x from 0 to 1 in the x direction. Let's first take a look at what this means graphically. On the right hand side you can see I've plotted the graph of y is equal to 2x. Now if we integrate the function 2x from x is equal to 0 to x is equal to 1, so from there to there, we effectively find the area under this graph denoted by this shaded area. So as this area is a triangle, we can calculate it using the following. Area is equal to half times the base times the height. This is equal to half. Now the base from 0 to 1 is just 1 and the height is 2. There's the height multiplied by 2. So the area in this case is 1. Now let's integrate it and see if we come up with the same answer. So we're going to integrate the function 2x from 0 to 1 in the x direction. So this is the same as saying 2 times the integral from 0 to 1 of x dx. This is 2 times x to the power of 1 plus 1 divided by 1 plus 1, because n in this case is 1. And as always, we have a constant c. This is equal to 2 times x squared divided by 2 plus the constant c, which is equal to x squared plus c. Now, as we're integrating from 0 to 1, this is written as x squared plus c from 0 to 1. Now, this is x squared plus c at the value of 1, and we subtract x squared plus c at the value of 0. So if we put these values of 1 and 0 into these expressions, we get 1 plus c, and if we put 0 into x squared, it's 0, so minus 0 minus c. The c's cancel out, and we're left with 1. So the area again is 1. So just using this simple case, we can show that integration finds the area under this graph.